So that is all ways of making that. So here, somebody is talking of making waraji. How do you make waraji? There's one from somewhere. How do you make waraji? Because waraji is alcohol. That is different. There are those who make it from cassava flour.
What of sugar cane?
This one of sugar cane is here. Somebody knows the one of making sugar cane?
I only know sugar canes only.
Okay, so somebody talked of preparation of ethanol from the ripe banana. This is one of, where is Farouk? Farouk, are you there? Eh? Farouk is not
He's
yet
not
here.
there.
So from ripe banana, you say ripe bananas are squeezed to obtain the juice. The juice is filtered to remove the salty particles. The juice is mixed with roasted sorghum flour and the mixture allowed to ferment for 1 to 3 days in a warm place. A crude form of ethanol, locally known as tonto, is obtained. So is that the correct procedure? Huh?
Yes.
Yeah. So uh, somebody says you ripe bananas. Those are the embedded, the ripe ones. To get them, squeeze them to obtain a juice. So the way of squeezing them is to step on them, and maybe to get the juice, you add some water and then filter. The juice is filtered to remove the salty particles. That's why they use the grass locally. The grass is used for filtering. They don't use these other filters or the sieve. They use the grass to get the juice very fast. The juice is mixed with roasted cassava, sorghum flour. This sorghum flour provides an enzyme that yeast would have provided, isn't it? So the mixture is
Yes.
allowed to ferment for 1 to 3 days in a warm place. Then a crude form of ethanol known as tonto is obtained. So that is one way. So beer is made from fermentation of starch in a barley. Wine by fermentation of sugars in a grapes. Spirits are obtained from distillation of dilute solutions produced by fermentation, and therefore, so these are some of the ways. But let's look at these ones here. Preparation of ethanol. Ethanol is manufactured or prepared by process of fermentation of carbohydrates. Carbohydrates provide us starch. In human beings, the starch is stored as what? Glucagon or glucogen? What is that? Starch stored in human beings. You have done nutrition in biology.
Glucogen.
Is glucogen. So that is the way starch is stored in human beings, but they are all starch. So in the plants, they store theirs as starch. If humans eat that, they store it as glycogen. So and sugars. So fermentation is a process in which carbohydrates like starch and sugars are converted to alcohols by enzymes. That is fermentation. So if enzymes are not there, then that's not fermentation. Like bushera, if you get flour and add water and leave it for 2 to 3 days, it will turn sweet. If you don't put any enzyme there, then it will not ferment. That's why the sealed there's that sealed whatever of bushera. If you find it in the shop, it will never turn to something alcoholic. It will remain the way it is. But if they add something that makes it ferment, it will go to alcohol stage. So that is part of that. So the enzymes break down the glucose. The enzymatic breakdown of glucose yields simple compounds like ethanol and carbon dioxide. Some heat is generated. Fermentation takes place in presence of oxygen. So those are some of So if it is starch, this is what happens. Starch is heated with the malt at a temperature of 60 degrees Celsius. This is in the factory. This is what they do. Malt contains an enzyme, diastase, which hydrolyzes starch into maltose. Now you realize that when starch is C6H10O5. In the presence of water, it goes to maltose, which is C12H22O11. Now, if you only remove
All right.
this water, the thing is like this. It is C12H22O11. If you only remove this, it becomes H22O11. So if you look at this, 22 and 11, they have a common factor. What is that common factor? It is 11. So if you pull out 11 molecules outside, it becomes H2O. So in glucose or in maltose, we have 11 molecules of water. Okay? That's why instead of this, glucose here or starch is this. So in the presence of water, it gives us that. So it has 11 molecules of water. This one is what we call maltose, and then maltose is this one here. This is maltose, the one that has 11 molecules of water. So starch in presence of water gives us that. So yeast is added at room temperature to the mixture and left to ferment for 2 to 3 days. Yeast contains two enzymes, that is maltose and zymase. These enzymes convert maltose that is provided to alcohol. So the hydrolysis is like this. Now this one, maltose in the presence of water gives us the glucose. So that glucose with enzyme zymase catalyzes the breakdown of glucose into ethanol, carbon dioxide, producing heat in the process. So the end product is, so the stage starts from here. Our starch is C6H12 of H10O5, sorry, O5. That is the starch. If you add water, it shall make maltose, which is C12H22O11. If you look at this is C6. So for those who know how to balance equation, these are 12 carbons, these are 6. So if you put 2 here, it means that these are 12 carbons, 12. These are 20 hydrogens plus these 2. 20 plus 2 to make 22. Then these are 10 plus 1 to make 11. This gives us our maltose. Now this maltose, we add yeast to it. Yeast has two enzymes. The first enzyme is maltase and then zymase. Now maltase works on the maltose. So it becomes C12H22O11 in the presence of another water molecule. It will give us glucose, which is C6H12, and then this is C12O6. So now, this one, if you remove water from glucose, from maltose, here, it will give us glucose. This is our glucose. Now, this enzyme that is left, zymase, will work on the glucose to give us C6H12O6. It will give us something like this. It will give us alcohol called ethanol. which is C5, C2H5, OH plus carbon dioxide and the heat. So this one, if you try to balance, these are 6 carbons. These ones are 2, these ones plus this one, those are 3. What should you do to balance the equation? You put 2 here. So those are 2 carbons. Now these ones are missing. These ones are 2 plus 2, 4. They are not yet 6. So these are 2. This one is full. So we add another 2 here. So these ones are 4 plus 2 to make 6. So carbons are balanced. Let's look at hydrogens. These are 2 plus 5. So these are 10 plus this one to make 11. No, these are 2. 2 plus 10 to make 12, which is 12. So these 2 multiplies everything here. So it becomes 2 times these ones, which are 10 plus these 2, make 12. Then O6, which is this one, these are 2 plus 4 to make 6. Therefore, our equation is fully balanced. So the end product is ethanol, and the carbon dioxide is given out and some heat that is provided there. So the crude ethanol produced can then be concentrated or purified by fractional distillation. You know what we call fractional distillation? Fractional distillation.
Yes.
So if you want to separate those, if you want to concentrate that ethanol, you use fractional distillation. Locally in villages, they use simple distillation, where they get that crude extract of adding, is it cassava flour, yeast and what. Then after that, they put it in some, is it a drum or something of the kind. Then they use those delivery tubes with some cold water somewhere. That cold water condenses the vapor from that boiled tank or boiled whatever. That vapor comes out through the delivery tube straight to the water that has been condensed somewhere. That water turns the vapor into liquid, and therefore that liquid flows into some container or jerrycan as a liquid. And that is the local way of making water ghee at home. For those who know, the drum will be here with some heat. I'm just drawing a sketch. So this is your water here. This is water, and this is now the crude extract. That one you get from adding, is it cassava flour with yeast, and that one they have fermented for some about 1 week or 2. They pour it here and heat the mixture. So when they heat, the vapor that will come out will pass through this delivery tube to the water that is here. That water will condense the vapor and make a liquid. The liquid will flow into the jerrycan as alcohol. That one they collect is alcohol. So the more times you bring this alcohol back to this container, the more concentrated it will become. So out of this, you can still keep this and bring it back to this drum and reheat and boil. The vapor that comes out will be more concentrated than the first alcohol that was here. And that's what they mean by distillation or fractional distillation. After that, they obtain their alcohol from that. So if they ask you questions here, you try and get ideas of going with that question. So this is from millet, and then from ripe bananas. Uses of ethanol are known. It is an alcoholic beverage like beers, wines, and spirits. It is also used as solvents in paints. When they want to make paint dilute, they put some ethanol and they stir. That one, in simple terms, they are dissolving that paint. and so that you can paint easily. So it is also used as fuel. Who knows why they use alcohol as fuel? Uh-huh. Where do they use alcohol as fuel? In the car? Huh? Where? Yes? Where did they use that? It is used as a preservative and a sterilizer. This one preserving most body tissues. They put them in alcohol and then they put formalin later. But if the thing is still fresh, they first add alcohol. That alcohol is almost 70%. So if alcohol is 100%, it is purity 100%. They get 70 of this and add 100 of water, or they add 30 of water to make that alcohol 70%. That one is used as a preservative and a sterilizer. In most cases, those who get wounds, what they wash you with that. So it is used as a thermometric liquid. That one, there are some thermometers. There are some thermometers that they use it as a there's a thermometer, they pour alcohol inside and they put some color there. You know it is colorless, but they add some additives there and it continues. So teacher, what if I say it is used for making sanitizer? Yeah, it is true. They use it for making sanitizer nowadays. Those days it used not to be. It used to be there, but in small amounts. But these days, everyone can see that sanitizer is there. So it is used as a. So finally, is there anyone who has a question? Anybody with a question so far? Hmm?
Excuse me.
Yes.
Won't they ask for the disadvantages of ethanol?
Disadvantages of ethanol.
Yes.
You know some disadvantages of ethanol?
Yes.
Like which one?
Yes.
Like which one?
Fire hazard.
Huh?
They are flammable.
Like what?
It's highly flammable.
It is highly flammable. Uh-huh.
It
Leads
can
to
lead to diseases.
respiratory diseases.
Respiratory diseases. Does it bring respiratory diseases? So
It can lead to overfeeding.
anything we have on earth is dangerous as long as you use it in the wrong way. If they give you something that you take, this is what you're supposed to take, and then you continuously add yours, then it's going to be dangerous to your life. Even alcohol, we have seen polythenes also are good. At a certain time, it is bad. Even alcohol the same way. So if they ask for the disadvantages, please make sure you write. Okay? Yes?
Yes.
Good. So I want us to finalize with the soap and detergents. We see soap that is in the form of bars. We see soap that is in the form of omo. Then we see soap in the form of liquid soap. Do you see those forms? Now,
Yes.
the bar soap has a large surface area. Is it large or small? So it has large surface area. What about omo? Which surface area does it have? Mm. Omo has a Omo also has a large surface area, isn't it? Yeah? So Omo has small already surface area. Now Omo diffuses fast in water other than the bar soap. And that's why most people use it as they use them for what? Soaking clothes. You don't use bar soap to soak your clothes. They use Omo to soak because Omo diffuses very fast and can attack the dirt as fast as that. So a person who has soaked clothes using Omo finds it easier to wash than somebody who has soaked them in water and then finally uses the bar soap to wash. Now, the factor that causes that is the two ions that cause softness and hardness in water. What are the two ions?
And potassium.
Huh? We have magnesium ions
Magnesium ion.
and, and the calcium ions, isn't it? Those two, when they are present in the water and use a bar soap, you can even use as many bars as you can to wash some good number of clothes. But with the presence of Omo, these ones can be reduced somehow and you find washing easier. So here they are saying soap is a sodium or potassium salt of a long carboxylic acid, of a long chain of carboxylic acid. Now, we have not looked at the carboxylic acids as part of organic chemistry, but it is also there. Carboxylic acids. Now, when you look at carboxylic acids, they are end products. Alcohols have a functional group as OH. Carboxylic acids have C double O and H at last. So if you see something written like this, COOH, then you know that is a carboxylic acid. Now, if the first carbon atom is C and N is 1, carboxylic acids also follow the same idea. So it becomes C1H. The formula is CnH2n plus 1, COOH. So if C is 1, H is the first carboxylic acid is methanoic acid. It is methanoic. So when you hear something called methanoic, you know the name is from a carboxylic acid. If the general formula is CnH2n plus 1, COOH, the first methanoic acid is CH3, COOH, and the name is called what? Methanoic acid. If another carbon is, if N is 2, it becomes C2H, H5, COOH. So what is the name of this? What's the name of that acid? Carboxylic acid. It is ethanoic acid. Then we have propanoic acid. Those names come from that. So all these are part of carboxylic acids. That's where they get their names from. So here they're telling us that soap is a salt of potassium, or sodium of a long chain carboxylic acid. That is soap, long chain carboxylic acid. So it is either potassium or sodium salt. So that is part of that. So manufacture of soap. So the common name for soap is sodium or potassium stearate. It is called sodium or potassium stearate. So in simple, if you want the symbol for this, it becomes sodium stearate or potassium K stearate. ST, that is stearate. So if you want to manufacture soap, the process of making soap using alkalis or fats, oil esters is known as saponification. So what is the process of making soap called?
Saponification.
Saponification. So saponification is a process of manufacture of soap. Manufacture of soap. Now, these are the things they use to make soap. Vegetable oil
Vegetables.
from coconuts, groundnuts, cotton, that oil. So these are the apparatus or the instrument they use. They use vegetable oil. So if oil is not there, they use the fats, in brackets, animal fats. That's what they use. That's why all soaps you have there in that state, so that fat from cattle or sheep. Then they use concentrated conc, sodium chloride, sodium hydroxide. That's what they use, concentrated sodium hydroxide solution. And then, so here they are saying boil the vegetable oil. So here we boil the oil or the fat with concentrated sodium chloride, sodium hydroxide, I mean, with concentrated sodium hydroxide solution. We have known this is our alkali, but we concentrate it until a uniform solution is obtained. Allow the solution to cool. Allow that solution to cool. When you allow it to cool, concentrated solution of sodium chloride, the brine, is precipitated out. So sodium chloride is precipitated out in the process of cooling. Sodium chloride precipitates out. You know the meaning of precipitation? Huh? You know the meaning of precipitation? So it precipitates out the soap which floats on the surface. So the soap got is a combination of this. So when this thing comes out as the solid or something like solid, it floats on top of the oil. When you mix these two, the vegetable oil and concentrated sodium hydroxide, the end product is a concentrated solution of sodium chloride, the brine. No, sorry. The soap precipitates out. When you mix these two, what happens is this. After mixing oil and the sodium hydroxide, those two things will give us a uniform mixture. Now, if you want the soap to come out, clearly, we add salt. And the salt they use is not the salt we eat at home. They use the salt from the lake or from what? The ocean. Or those. So that salt is called brine. So it is concentrated. So they add concentrated salt, which is sodium chloride. That one from the lake, not this one we eat at home. Then when you add this, the soap will be precipitated. This one, the work of this concentrated sodium chloride or the salt is to precipitate out the soap. Precipitate out the soap. Now, when this soap is got, when you get that soap still has some impurities in it. So what they do to remove those precipitates, this one comes with the glycerin and something of the kind. So that glycerin is bad for the body. So what they do is they add some disinfectants like now that soap is in form of oil or in form of fat. That brown soap. Actually, have you ever seen that soap that looks like yellow? It's not yellow as if it has the color of the fat inside. You normally see that soap there. Let me give an example. There's that soap that is from Mukwano that is always yellowish. Do you always see that soap? Yes?
Yes.
No. Now that one is got
Yes.
straight from adding the salt. When you add the salt, it precipitates out the soap. Now that soap is always like that. But if you want to change the color of that soap, you add perfumes, some dyes, disinfectants, and then like this toilet soap, you put some disinfectants in it. So that soap is not good to be used for bathing. But geisha, they add perfumes and some dyes, and that is the scent it has. So the process of adding sodium chloride to the boiled oil and concentrated sodium hydroxide is known as salting out. So that soap will float on top and they collect it and gather it, cool it, and then they start forming bars out of it. They shape it and push it to the next machine, and that's how that soap comes out. So here they are saying concentrated solution of sodium chloride brine is added to precipitate the soap, which floats on the surface. The process of precipitating the soap is known as salting out. The soap is then removed and treated further to produce pure soap. That is what we have. So perfumes, some other things are added, but this bar soap always has that natural scent of the pure soap from there. That soap without the scent, they add a little of the perfume to confuse that fat a little. So this one represents the long carboxylic chain, COO, R bar plus sodium hydroxide. It gives us this, which is sodium. Now, there is when these acids react, they form ethanoids. So here we have something like sodium ethanoate plus this, but in general, just know the procedure. These equations, we shall put them right uh, on Saturday as we finalize. But for now, just know the process of boiling oil and concentrated sodium hydroxide. That uniform mixture, if you want to remove the soap out of it, we add the salt called sodium chloride or the brine. That salt from the, the lakes, like that one from Katwe. You can't add this purified one of ours where they have put some elements. So there, we use the other concentrated solution of that sodium chloride from there. When you put it there, you see the soap floating on top. So you get that soap, cool, and cut it into different shapes. If you want soap to change state, you add perfumes, dyes, and disinfectants. Do you have any questions so far? Any question? Amida, Lynette,
Yes, teacher.
questions? I thought we would finish this, but this whatever has made the Mwenge Brigade has made us more active and so that is part of that. So do you have any question before we leave the session? Yeah? Yes? Why do we add concentrated sodium chloride to the solution of oil and concentrated sodium hydroxide? Yes? Tracy?
Pardon.
Why do we add sodium chloride or concentrated solution of sodium chloride to the boiled solution of vegetable oil and sodium hydroxide.
To precipitate the soap.
Precipitate the soap. How do we call this the process of soap manufacture?
Saponification.
Saponification. So from actually when we meet next time, we shall look at that cleansing action of soap. We shall see the hydrophilic head and the hydrophobic tail. Hydrophilic and hydrophobic. So somebody should tell us what hydrophilic means and hydrophobic. There are those people who fear water. So you should tell us the difference between those two words. Hydrophilic and hydrophobic. You have data, make sure you look for the meaning of those two words. Okay? Look for the meaning. So I think I will come with a small video of how soap is made, and then we shall watch that and finish. So we shall see soapless detergents, the difference between detergents and that. Then all these questions are there for you to try out. If thin can undergo polymerization, explain what the term polymerization of thin means. All these questions are there in the book. Okay, so all these questions, please make sure you try them out, because after that we shall not come back to organic chemistry again. Actually, half lesson on Saturday will be to finish this. Some 20 minutes are enough. We'll cross over to the next point of discussion. Okay. So, has the program helped you or not?
Yes.
It has helped a lot, isn't it?
Yeah.
Yeah. So for now, people know how to make soap. They know what the high density polymers are. Even now, people know how to make alcohol. Yeah?
Yes.
So all those processes are there. So in the meantime, allow me end the session. Senior series, I think you have a lesson after this. We shall meet again on what? Saturday? Okay. If there is nothing, I wish you the best of the day. Okay? Or somebody has something to say. Huh?